Everybody was here, but this is part 1 demo. Depending on which day you give, Wednesday or Thursday, Parth left this information. The other is related to test 2 and the makeup exam. Some of you had approached me on Monday suggesting if it is possible or if it made sense to take the makeup exam earlier and test 2 later. So kind of, not having them on the same day. Okay. To which I am open to the suggestion. My only condition is I will give the makeup exam only on one day. So as a class we have to choose whether we want it before test 2 or with test 2. Okay. I will not make exceptions that 5 people take here and 15 people take there. That's my condition. I am open to that suggestion. So on that note, I want you to sign on this thing. I have 2 sheets that I have for you. First one says test 2 and makeup test to be taken both on Friday, December 2nd. I am requesting, I want to find out what is a more convenient time. One possible time slot is 11 to 1 and the other is 1:30 to 3:30. Put your name, both, so write your name 4 places and put a check or a cross next to it. Check will mean it is convenient for you, cross will mean it is not convenient for you, and so your name should be on all 4 things indicating whether it is convenient or not convenient. Okay, to indicate the choice, so if, for example, the other sheet says that you take the makeup test on November 18th, which is not this Friday but the next Friday. I cannot give you on the November 25th because it is Thanksgiving break, and the Friday after that is December 2. So you are taking the makeup on November 18 and the test 2 on December 2. If you don't want that option, you can write your name and put a cross on both. Okay. So here I am hoping that one of them will be a check mark. Here is totally up to you whether you want it decoupled or you don't want it decoupled. If for any reason both of them are still inconvenient, then please put a check mark. I am in cross against both of them, and then we'll try to figure out what else can be done. Okay, I am trying to keep the lecture class for lecture. If worse come worse, we'll do it on a Wednesday, and then I'll have to assign some parts as a reading assignment. So again, I'm trying to make sure that we don't have to do a reading assignment, but whatever it will need to be done. So make sure you are writing your name 4 times and indicating what is convenient and what is not convenient. Okay, so that is going along. Here it will also serve as today's attendance. It has been a while since I took attendance. While you are doing that, today I am going to talk about polymorphism and specifically virtual functions and pure virtual functions. I'll let you get over with part 1 demos. Project part 2 will be posted on Friday, November 11, and Monday class I expect to discuss project part 2, and what will remain from the chapter 5 is runtime type identification. That I will do there. So polymorphism is chapter 5. Okay, so over the weekend it is okay, or I would suggest, if you are not comfortable, don't implement project part 2, but read through the document that is posted. That will be very helpful when we are discussing it on Monday. That will give you a time over the weekend to read through this and have your questions answered on Monday. Okay? You will still have interim presentation to do next Wednesday, Thursday. So I will specify what you want to do. It would be something on the lines of have your header files ready. So you may not, may not be a working demo because you will only have time between Monday and Wednesday. But I think that is plenty of time to put your header files together and do the implementation afterwards. But putting your header files will be a lot faster if you have read through it, have your own questions, have things in your mind kind of ready, so that between Monday and Wednesday you can just put in your header files. You can do your implementations afterwards. Okay, so that is what will happen with the project. And polymorphism is divided into these things. I like to give you some time to digest this before I talk about runtime type identification. So that is why I'm not going to talk about it here. Use your weekends also to read chapter 5, which is polymorphism. A good understanding of chapter 4 and chapter 5 is imperative to your project and is imperative to how you do on your test 2. One of the questions that was asked after chapter 1, after test 1 was, how do I prepare? Here is your answer. Read and just understand your chapter 4 and chapter 5. Absolutely a key on how well you will do on your test 2 or not do on test 2. Okay, that is where the information is. So let us start with this chapter 5 here. We talked a little bit, but I still want to, it's better to repeat. Polymorphism in C++ is a question about compile time binding versus runtime binding. Okay, so the same function can use compile time binding at some times and runtime binding at other times. So a function in C++ is not polymorphic. A function call in C++ is polymorphic. If the function call uses runtime binding, we say it is a polymorphic call. If a function call uses compile time binding, okay, then we say it was not polymorphism. The same function can be polymorphic at some times and non-polymorphic, if I might use that term, at other times. Okay? So if you, for example, in context of our project, we talked about the display function, right? So every call to the display function will not be polymorphic. But some calls to the display function can be polymorphic. Okay? So that is why the first concept to get crystal clear is a function is not polymorphic, a function call is polymorphic. What needs to be true for a call to be polymorphic? Yes. That the function is called through a base class pointer, and that covers the inheritance. Okay, and that the function should be virtual. Okay, so when a function is declared to be virtual, it has the possibility to be a polymorphic call. It will not always be polymorphic. It can sometimes be polymorphic. Why? Why did the designers of C++ choose that way? As students, our life would be simpler if we saw the keyword virtual and we said, oh, it's polymorphic, right? Versus worrying about all this. Why did the implementers of C++ decide that the same function could be polymorphic or not polymorphic? What's good about a polymorphic call?
Runtime binding.
Why is runtime binding appealing?
Because we don't we get a single function call. Any we don't have to design separate functions to call different functions.
So same function call could be be a function call for many different functions, right? So it gives me flexibility, right? So if I might now use your part 1, if I call the display method, it could be the display method of the green mouse dice face, or the red mouse dice face, or the green bold dice face, or any other dice face. I don't have to check what object it is and then call the method. I can simply call that method through a base class pointer and it will automatically decide which one it is. So it gives me a lot of flexibility. That's the power of polymorphism. Okay? What is the price I am paying for it? Runtime, execution time. Any decision that has to be made at runtime increases the execution time. Okay? So don't think polymorphism comes free of cost. There is nothing like a free lunch. There is always a hidden cost behind it. If you were not charged up front, you were invited for a free lunch, then you have to look behind, right? There is a subtle reason behind it why you were called. There is nothing like a free lunch. Same thing here. It looks like it is very flexible. It makes life a lot more powerful. But what is the price I am paying? The price that I am paying is that this call will take more time. Why? Because it has to find the appropriate function. The binding of the function to the call happens at runtime. So it is at runtime I am going to check. Typically what is done? We check the type of the pointer and call the method of that class. But now I want that extra step. Don't only check the type of the pointer. Go ahead and check what is the type of the object it is pointing to. Then go to that function call. That makes me use that same function call for 8 different possible kinds of behavior. But I have to do those kind of checks at runtime. Actually, there are 2 penalties I pay, or 2 overheads I have. I have a storage overhead. Virtual functions have what is called as a V table. They have to maintain a V table. So there is that storage overhead. Now over the years we say storage is no big issue. Memory is cheap, I don't care. But there is also that virtual table lookup penalty, which is the time penalty. That we worry about because it's all about speed in the software world. So there is a time penalty also. Okay? So that is why now you will probably appreciate what did the designers of C++ do. They said we will use runtime binding only when it is needed. or essential. So only when that function, that virtual function is called through a base class pointer, they say, okay, now it is absolutely needed, I will wait till runtime before I make the binding. Otherwise, that same virtual function, if it is called through an object, right? You declared a green bowl dice face object and called the display method. There is no guess to be made, there is no reason to wait till runtime. I know which display function has to be called. That is bound at compile time. That is why C++ is still one of the more has a faster implementation or execution time for programs. Although, I like to mention it because it is appropriate, we don't talk too much about it in general in a C++ class. Anybody know the language that has been said to be purely object oriented? No. Small talk. You know why? Because everything there is an object and every function there is polymorphic, and the only thing it uses is runtime binding. So the good news is, if we learn Smalltalk, you don't have to worry about all these different things. That is the only way things happen. I won't be talking about runtime binding and compile time binding. I'll just say that it is bounded. That's the only thing that happens there. But a comparable Smalltalk program runs how much slower? 10 times slower than a comparable C++ program. Let's see. Okay, so there was a lot of wisdom behind keeping this both. See, what is the parent language to C++? C. Okay, why was C popular? Or why were languages at that time, what was the hallmark of those languages? Was speedy execution. So as we moved from structured programming to object-oriented programming, okay, there was this idea of making things modular, of keeping data secure, of increasing the maintainability of large software projects. But also equally important was not to sacrifice speed over all this. And the implementers of C++ saw that. So that's why C++ or Java, for that matter, you can do programming which is not object-oriented, which many times we start as in this course also, right? Remember the times when we came up with saying I have a hard time putting the file into class, I can solve the problem as one program, I can solve it in one file, but I have a hard time in putting in different files, right? A lot of us start from that point when we start this course, so we were actually doing imperative programming using C++. So the power of C++ lies in being object oriented, but they were wise enough to say, okay, they put enough thought into keeping it still a speedier language. It's not as fast as C, but it is not as slow as many other object-oriented languages that were designed. Of course, none of them is now a popular language, so to say. It was easy to see. So Smalltalk is very simple to learn because it is very orthogonal. There are no exceptions to rules, so to say. But the price comes as being a very slow execution time language. Okay? So that is why we have to learn this. So the de facto or the default behavior is compile time binding. We always use compile time binding unless it is a polymorphic call. That's the only time in C++ that runtime binding is used for the function calls. Whenever we are talking about binding, what does binding mean?
Linking.
Linking. What are we linking?
Call to
Call to the function definition. That's the binding we are talking about. Okay? The function call to the function definition. Which function definition am I going to use? In C++, many other languages, and that's the other course we talk about, there I typically tell them think of it loosely. Here you have to think it in terms of C++. Polymorphism, okay, if you look at the root of the word, poly means many and morph means forms. Okay, so it's many forms of something. Function overloading, now I bring back function overloading, name hiding and function overriding. What is common about all of them? We are talking about two functions using the same name. Okay? In C++, function overload, anything other than function overriding, where we are using a polymorphic call, is called pseudo polymorphism. Pseudo means fake, false, right? It is pretending to be polymorphic, but it is not really polymorphic. Why is it pretending to be polymorphic? Because the name is the same. In overloading, what is the case? Name is the same, but two different behavior. I can add 2 integers or 3 integers. I can display a character or I can display a integer or an array of integers, whatever, right? So it is like same name but different forms. But why in C++ it is called pseudo polymorphism? Because it does not use runtime binding. At compile time, the function call, looking at the function call, I can make out which function is being called of the two overloaded functions. Because, why can I make out? What is different about these overloaded functions?
compile.
Virtual came lot afterwards. This is coming from your test 1. Function overloading can use compile time binding because what is different for these functions?
The function definition.
Signature. Function signature is different. Function signature is unique for overloaded functions. Then when we talked about inheritance, we looked at name hiding. Functions again had the same name. What about the signature? Don't care. Can be same, can be different, I don't care. It's, as I said, it is a byproduct of inheritance. We had to talk about it because what if the child class used the same name as the parent class? Okay? And now in polymorphism we'll see again another occurrence of functions with the same name. Now signature has to be the same. It is real polymorphism because it uses runtime binding. If you have to use one definition for polymorphism, polymorphism happens when runtime binding is used, period. Forget about everything else. It's as simple as that. Okay? So when do we use polymorphism? When runtime binding is used. Okay? Same function can use runtime binding and compile time binding at different times. That is why function call is polymorphic. The function itself is, we call it a virtual function, whatever, but we cannot say this function is polymorphic because it may not be using a polymorphic call at some point in time. The call will be either polymorphic or not polymorphic. Okay? So that's one thing to remember about polymorphism. And when the function uses runtime binding, that's use of polymorphism. Know about, as I was talking about, function overloading. Name hiding. and function overriding. The only thing that has the potential to be polymorphic is a overridden function. Other thing that we will talk about today, or concept you should know, is abstract classes. And then we will talk about runtime type identification. Okay, this I will not talk about today. I will talk about on Monday, so you have some time to digest the rest. This is what I will be referring, and everybody is referred to as RTTI, is runtime type identification. Okay, so again we'll start with right from the beginning. Okay, so I'm starting with a top level function. There are no classes. Yes.
Ma'am, basic question. I mean, why exactly are we using polymorphism when we know that it consumes more time since it's runtime binding?
Because otherwise, how do I do? How do I decide between which function should be called?
Depending on a condition, I can directly call a function rather than pointing my base class pointer to it.
But what if I have to, let's say, I'm putting a very simple example, right? Let's say I have a base class pointer, right? Let's say I create an array of your 6 dice faces, right? Now forget about all the probability etc. I gave you. But instead I said ask the user what dice face. So the user can decide. Let's say 6 people play the game, everyone gets to choose a dice face. So now if you implement it, you will have a cout statement saying what dice face you want, right? And depending on what I've got, I would create that dice face object, right? So now either I don't create an array, so then I will have those objects created accordingly. Remember, because you are creating the object based on an if-else statement, right? So you will have that much of the, you will be there will be no common thing that can point to. They will be all different things. You cannot put it together. You know what I am saying?
No, but what is the advantage? I can call the function directly. For example, if I have, let's say, green sleeping cat, a function, I can call it directly from that class.
But then I have to have a green sleeping cat object being allocated, right, beforehand, and it would not be in an array.
Right.
Do this. Try to write code, okay, and if it takes too long, don't do it, but it shouldn't take too long. You all are writing as part 1 code an array, creating objects and calling the method. Do that without using polymorphism and see the difference between the amount of code you have to write. Should give you your answer.
Is it because the reason we use polymorphism, is it because we don't have something like a list in C++?
No, there is a list in C++, or you can create a list in C++.
So,
Like another way to think of it is, or another aspect of it, if I have to create, I have to store 3 different kind of objects in an array, how can I do it?
3 different types. Usually when we use a list object or an array list.
So what I want is, let's say I want an array of size 30, which would sometimes contain an integer, an element could be an integer, sometimes a character, and sometimes a string. What is the solution to that problem?
Create a class which has all 3 of them.
Okay.
Store it as data.
And create an array of that class, right? Now what are you doing?
Creating different.
Yeah, that's a possible, that's a solution, I accept it. Okay. What is the problem with that solution? No.
We have to create the object of the class.
An object, let's say a character takes 1 byte, an integer takes 4 bytes, and a string takes 8 bytes. Every object will take how many, and let's say there are no other members. So 1 plus 4, 5 plus 8, 13 bytes for every object times 30, right? So for an object there is 13 bytes. How many bytes will you ever use? Either 1 or 5 or 8. Multiply times 30, at least 6 are wasted. I am assuming string is being used, right? You are using 8. 6 is always wasted, at least 6 is wasted. 6 to 14 is wasted if there is a character, times 30. Do you see the big wastage, right? Another solution with equal wastage. I create 3 parallel arrays, one of type int, one of type character, one of type string. And then I store accordingly, and I do some default value like a -1 for integer, which means this I am not using. Right? So first element is a character, I store in the 0 a subscript of character array, in integer I have a -1, in string I have an empty string. The second element happened to be a string, I store in the string, in the integer I store -1, in the character I store whatever default value. Right? So for a given subscript I will use one of the arrays, the other 2 will have a default value. Same kind of wastage, another solution. A third solution, I create a hierarchy. I create a node, have 3 children, an integer node, a character node, a string node. Integer node has 1 integer, character node stores a character, and string node stores a string. Now I use a node pointer array. Now I can create an array because node is the same data type. So I can create an array of size 30 of type node pointers. Node pointers can point to any of these 3 objects because they are all child classes. So now I have a size 30 array with different kind of data types. So it's a much more efficient implementation, plus I can use polymorphism. Now I don't need all that if and else code to see what is the type of the object to call the method. Okay, so these are 2 big reasons. In short, we use polymorphism for flexibility. Polymorphism is about flexibility. We call power because of the flexibility. It is the power of flexibility, if I might say so. Okay? So here through this handout, I am taking you on a journey from where you learned functions in the first place. You didn't talk about classes at all. So we are seeing a function f1 that has been defined. Okay, all we have, you see a lot of blank lines, don't worry about it. The idea is that there is a function f1 and it is called in the main method. What does the executable look like? The executable looks like, let me do this actually. A little bit of code space. So the executable looks like, here could be the code of F1. Let's say it's at memory address 300. At memory address 500 starts the code of the main function, right? Somewhere in this code, okay, so compiled code of function f, compiled code of main function. One of the lines in the main function is the call to f1. Okay, so what does that call look like? Execute code at 300. Okay, so the execution control jumps here, executes and comes back. Okay, very elementary, nothing big, but that is where we start. That's how a function is called in C++ or in many other languages. This is a very generic thing. Now let's say what happens when a member method is there, right? Another form of function or use of function we saw was functions could be members in a class. Now we have a class X which has two data members A and B and has a function f1 and that function f1 is defined outside the class definition. It's not inline. And then in the main function we are declaring two objects x1 and x2 of type x and calling the method f1 from both these functions. What does the executable look like now? The executable now looks like again we can assume function f1 is at memory address 300. Somewhere we have declared the objects x1 and x2. x1 gets enough memory to store A and B because those are the two data members. x2 gets enough memory to store A and B, right? Then comes the call to x1 dot f1, right? x1 dot f1. What will that be? That would be again jump at 300 and will use the data from here. And when the same function is called from x2, again it jumps at 300 but uses data from x2. Okay? All this is known at compile time. This binding can be done at compile time. I know I have to go to my memory address 300. Now comes a hierarchy. So class X looks the same that it did. Okay, it has A, B and the function f1. f1 has been defined. I now also have a class Y which has declared itself to be child of X, is using public inheritance, adds another data member C and a method f1. What will you say about the two f1 methods that you see?
Same function
Is it overloading?
overriding.
Is it overriding? Why is it not overloading?
Because
They are in two different classes. Okay, they are not together. They are not at the same level. Why is it not overriding?
Because virtual was mentioned.
Because virtual is not mentioned. Keyword virtual is missing. So what's the third possibility? Name hiding. This is a case of name hiding. The child class introduced a function with the same name that it had inherited. Remember the input method or output method in the film class hierarchy. This is a thing of name hiding. So let's look at what happens in the main function. Again, we've declared two objects x1 and x2. We also declared a child class object y1 called f1 through x1, x2 through f1, and let us also, I think that is right there, and also let's call this and we are calling the f1 through the base class pointer. Okay, so if I modify this here now I have, till this point it is same, or let's redo this. Now let's assume at 200 I have the class x f1, and at 300 I have the class y f1, right? There are two functions f1. One was defined in class x, the other was defined in class y. And then I have a main function. Let us again assume it starts at 500, for example. I'm just making up these numbers. Then I declare the two objects. So I have the object x1 has enough memory to store a and b. I declare the object x2, again enough memory to store a and b. I have the object y1 with enough memory to store a, b and c. Remember, class y also introduced another method, abc, right? Now I am making these function calls. So I have x1 dot f1, I have x2 dot f1, and I have this function called bp f1. Three calls to the f1 function. Which call should it call at x1 dot f1? Should it call 200 or the function at 300? So the call x1 dot f1 should be bound to the code at 200 or 300?
200.
Why?
First object.
Because x1, so this is how it works. It checks what is the type of x1. It is x. So f1 of x should be called. So this is bound to the code at 200. How about x2 dot f1? Same thing. What is the type of x2? X. So f1 of the x. So again at 200. What should the call f1 through bp be called bound to? What is the type of bp? It should. What is the type of bp?
X.
It's an x pointer, right? So that is what it does. It checks the type of bp. So should it call the f1 of the x class? Why the y class?
You have the address of y1.
Because it stores the address of the y1 object. So you now see here we have bp storing the address of, or pointing to the y1 object, right? Which will have enough memory to store ABC. So now when we call that method through BP, Here is a y object. Here is the pointer of type x. See the problem? See the confusion? So, what does it do? The language system like us is lazy. It will try to do the least amount of work. Okay? Even though I say lazy like us, it is done. Why does it only check the type of the pointer? Because that is faster. So the default behavior is fast behavior. Okay? So what would it do? Even though we want the f1 of y to be called. Why? Because y1 is of type y. What will really happen is, it will check the type of BP. BP is an X pointer. This will always be bound to 200. Okay? So, here is an example. We used a base class pointer, but the call is the call polymorphic? No. At compile time, it will be bound to the code at 200. What was missing? Virtual. It was not a overridden function. Okay? This is a definite question on test 2. What form it will come, I don't know. But in some way, I will try to find out that you know whether a call is polymorphic or not. A function can be called through a base class pointer and not be polymorphic. A virtual function, an overridden function, can be called through an object and it will not be polymorphic. You always have to check that the function is virtual, it's an overridden function, and it is called through a base class pointer. Only then is the call polymorphic. Okay? That is the basic understanding of polymorphism. And you have to know that part. Okay? There will be questions about it when you are giving your final project demos. There will be questions about it when you are taking your test too. So, know exactly. Yes.
So, Professor, if I do not inherit the second class, and
Right.
if I still create a base point, I mean, like, there are two different classes. I have not inherited, and I have created y1, and I have created x pointer BP. Still, can I call the other class also? If I have not used the inheritance?
No. No. If there is no inheritance, so anybody's pointer cannot point to anybody else. So a pointer of a type can either point to that object of that type or children of that type, which is also known as subtype. Okay, that's why in absence of inheritance, polymorphism cannot exist. Because the pointer, in absence of inheritance, the pointer of a class can only point to the object of that class. There is no other behavior possible. Only in inheritance, now not only can it point to an object of this class, but any children also. Okay, that's why polymorphism is possible. What if, so even though this is undesirable, this 200 is not desirable, but it happens. Okay? So even though the BP pointed to a y1 object, because it uses compile time binding, it will be bound to the f1 from the x class. Now you might say, why doesn't it know at compile time that it is storing the address of y1? Right? I see it in code right now. Right? You are right on that note. But you also have to see, I can easily change that code asking for the user input saying what object would you like it to point to, and make it in some cases point to an x1 object and x object, and sometimes to a y object. Okay, because a pointer can use the new operator and do that. Okay, so that is why here, because there is no overridden function, it just checks the type of the pointer and decides the function call. What if there was in the main function I had y1.f1? What would y1.f1, what will it be bound to? 300. Why? Because the type of the object is y class, and that also uses compile time window. Okay? So here we have come to a case, this one, where we want it to be bound to the function at y300, but it is bound to the function at 200. So how do we make it bind to the function at 300? Because that is desirable and that is what should happen. So you will see here the use of virtual. Okay? Everything else is the same. The only thing we did was add the keyword virtual before the function f1. Okay? Everything else is same. So there is there you see the use of keyword virtual, and in the child class you see that the keyword virtual is not used, right? So on that note, a couple of things to note about that. The keyword virtual, where the keyword virtual will be used is where the function will start to be polymorphic. Once it is polymorphic, it always stays polymorphic. So because in this example, the class X declared it to be virtual, okay, or overridden, from now this point on, F1 is always virtual. The fact that in class Y it is not declared to be virtual does not matter. Okay, so class Y is just overriding the function. However, a good programmer or a good programming habit is to put the word virtual in the child class also. It is optional. It does not matter whether you put the keyword virtual or not, but a good programming habit is to put it there. Why?
Might be the way
If tomorrow somebody declared Y to be a parent class, then they don't have to go up to X to see that it is virtual. It is right, the information is right there. So whether you write virtual or not, behavior wise it makes no difference. But it is a good habit so that tomorrow the children of this class don't have to trace back their step all the way up to figure out whether this function is overridden or not overridden. There is no way to say I am not overriding it. Either you will override it or you will inherit from the parent. But you will always have an overridden function. Remember, we inherit everything. Okay? And when you inherit a overridden function, it is always overridden. You cannot say I am making it not overridden. That is something you cannot do as a child class. Okay? So that keyword virtual in class Y is optional. A good programming habit is that put it there. Okay. Now you see, the only thing that is different is if the function f1 of class x is called, f1 of class x is called is put on the screen. If it is the y f1, then an appropriate message is put on the screen. Here you have the same main function yet one more time. So declaration of the two x objects, y object, calling of F1 through X1 and X2 and calling of F1 through BP. It's the same thing. But because of that keyword virtual, now it will be bound to the function at 300. What is happening behind the scenes? When it checks the function BP calling F1, the binding does not happen at compile time. Okay. At runtime, it will check what type of object is BP pointing to. It is making, we are requesting, so through the keyword virtual, we are requesting at runtime that please check the type of object this pointer is pointing to. At that point in time, it sees it is pointing to an object of type Y, and now go to the V table where we store all the pointers to the methods and use the F1 from the Y class. Okay, so overridden methods are stored in a virtual table. So one has a link to the XF1 and the YF1. So depending on the object that it is pointing to, choose the appropriate link to make the binding and call that method. To look up the V table and use that link is a little bit of indirection, which is coming as a cost of runtime penalty. And the fact that a virtual table has to be created and stored is the storage penalty. Okay. The advantage at runtime, you can, like you are doing in your part 1, right? You are based on the random, the input file that is coming in, you are creating the dice face objects. At different runtimes, your dice will have different dice faces. So whose display is being called will depend on which dice face that pointer is pointing to at that given run. So it is very flexible. So this seems to be a small penalty to pay for that kind of flexibility. Okay? So by itself, code-wise, it makes life a lot easier. All we have to do is put the keyword virtual. But you have to understand the concept behind it. Same thing as inheritance. Code-wise, did you have to do anything big and fancy? No. All you did was after the class name, that colon and the name of the parent class. Here you have inheritance. So code-wise, these concepts are very simple. There is not too much of additional code you have to write. But concept-wise, you have to understand how they function. Let's look at another example. So here is a transaction class. This is an example that uses a structure instead of a class, just for simplicity, so that all the data members have been made public instead of giving set get methods. Okay, a good class would have all that either private or protected and put the method into the public section and have set get methods. But so that we don't have to put the set get methods, we are using a structure. So struct transact has a character pointer, character array of size 20 called security. There is a buying price, a selling price, and then there is a profit loss. Okay, so the hierarchy you are looking at is a transact is your base class, and there are two kinds of transactions, a call or a stop. Okay, we have one virtual function. So the parent class is declaring it to be virtual. That's a profit loss function, which finds for a transact object it is calculated by finding the difference between the selling price and the buying price. Now we have your child classes. The first one is stock. It uses a public inheritance and declares transact to be its parent class. So it has inherited all that was there. Okay, including the virtual function, but stock says that is not how I calculate profit loss. For me to calculate profit loss, I have to add the dividend to that difference. Okay, so what does it do? It overrides it. It is redefining that. Okay, so you will note that the signature is the same. The profit loss in the transact class takes no parameter and returns an int. Same thing, I mean return type doesn't matter, but the name and the parameter list is the same for the profit loss in the derived class. This is overridden and not name hiding because of the keyword virtual in the base class. Okay, so this is not name hiding. This is overriding. And so it redefines the behavior there. It added a data member dividend, but that is about it. The second one here is the call class. Again declares transact to be the parent class, is happy with the behavior that the parent had described. So it says it works for me. So it does not redefine. So it inherits. Okay? Again adds a couple of data members. And here is your main method. It's kind of a mini method, same way like your dice function. So we create now a transaction array of transaction pointers of size 2. So we are using the base class pointer. We are creating a stock object, a call object, hard coding some values for the data members of the 2, and then making the first pointer point to the stock object and the second pointer to the call object, and then calling the profit loss methods. Here is your first example of a polymorphic call. You will see when I was going over the profit loss method, I did not use the term polymorphic function. I used the term overridden function. A call to a overridden function can be polymorphic. Give me an example of calling the overridden method where the call is not polymorphic. How can I call the method where it will not use runtime binding?
Create an object and then call the.
Give me an example from the code here. What line of code can I add, and that would be an example of an overridden method not using polymorphism?
S dot profit loss.
S.profit loss or C.profit loss. Okay. Here we are saying T0 profit loss, T1 profit loss. I could have it in a loop, and this could be Ti profit loss, right? And the same line of code will call profit loss of stock and profit loss of call. Now you see the flexibility, the same line of code, right? So that is the power of polymorphism at the expense of a small runtime penalty and a small storage penalty. Okay? But everything is not done runtime, doesn't use runtime binding in the interest of faster execution time, which has served the language well. Any questions till now? This is the basic of polymorphism. If you get that, pretty much that's what is there to learn in here. Okay, let's talk a little bit about constructors and destructors. Can a constructor be virtual? Or let me rephrase my question. Should a constructor is a kind of a function, right? Should a constructor be declared virtual? Why not?
Because constructors are not inherited.
Okay, let's say they are inherited. Then should they be made virtual?
No, knowledge is created only from constructors.
Constructor is called when an object is created. When an object is created, is there any possibility of that this object will be created or this class object will be created? If I say new X, an X type object has to be created. There is no way that a Y type could be created. So therefore, for constructors can never be virtual. Another thing that can never be virtual is a top level function. Can never be virtual. If you are not in a class, there is no need to be virtual. Okay? Constructors cannot be virtual. Top level functions cannot be virtual. How about destructors? When is a destructor called?
At the end of the program.
When the object is destroyed. Give me a code, line of code where destructor will be called, which uses a pointer. Let's say I used a pointer P to create an object. When will this object be destructed? Delete P, right? Now if this pointer can point to different kind of objects, right? In our previous example, if that transact array pointer, right, transact pointer could point to a transact object, a call object and a stock object. So when I delete that pointer, which destructor should be called? Only the destructor of the object that it was pointing to. If it is pointing to a stock object, stock destructor should be called. If it is pointing to a call object, the call destructor should be called. They both in turn will call their base class destructor. That's a different story. That's the story of inheritance. But where does the action start? Depends on the object it is pointing to. So it is not sufficient to check the type of the pointer. I have to go one step ahead and check the type of the object it was pointing to. And therefore, destructors should be virtual when needed. Okay? So that is the reason that the destructor should be virtual. It shows you a base class which has a method that says a base class constructor is firing, a base class destructor is firing, a derived class constructor is firing, and a derived class destructor is firing. What is happening here is, one second. So let's look at the main function. Let's look at what kind of things are happening. Base class pointer is created. Any constructor destructor fired? No. When a pointer is created, nothing is happening. What is a pointer? A pointer is just a variable that can store an address. No object is being created. A base class pointer created, nothing fired. Pointer, using that pointer we created a new derived class object. Which line will I see first?
Base class.
BC firing. Even though the derived class constructor is called, the first thing it does is call the default base class. So the first thing that happens is we see BC is firing and the character array of size 5 is created. Okay? Then DC, it will show that DC is firing and the 5000 size array is created. Okay? Then we come to the next line which says delete pointer. Now if it was not virtual, what would happen? What will I see on the screen? It will call the base class destructor because pointer as PTR is a base class pointer. What does the It will show BC destructor firing and will deallocate the size 5 array. We have a memory leak of size 5000. What did we want? We wanted the derived class destructor to be fired, called. Why? Because that is the object that is getting destroyed. Okay, so here what will you need to do is you will need to make the destructor virtual. Okay, so I highly recommend, this is a complete program, type it, copy, I will have this available on the Canvas site, copy, paste, run this and play with it to understand that. Okay, so unlike inheritance where constructor had all the rules and destructor had no rules because there was only a default destructor to call base class, here the destructor can be virtual, constructor no issues. Okay, I will stop here, I believe time is over. So I will do the second handout on the pure virtual methods and RTTI on Monday in addition to the project part 2.